Hello my dear students, welcome to my channel. In the before class, we have discussed about variable separable method. Today, we have to discuss about homogeneous differential equations. Okay, before solving homogeneous differential equation, first of all, we have to know what is homogeneous function. Look at very carefully here. A function f of xy is called a homogeneous function in x and y of degree n if f of tx is equal to t to the power n f of xy, where t is independent of x and y. Okay, the definition is quite simple. A function is homogeneous if f of txty is equal to t to the power n f of xy and the power of t is the degree of the homogeneous differential equation. Taking an example. For example, look at here, if f of xy is x square plus xy, then what is the degree of this homogeneous differential equation? Tx ty, then t square x square plus tx ty. So this is t square x square, this is t square xy. So taking t square common on both the sides, we get x square plus xy. Okay. So this one f is a homogeneous function in x and y of degree 2, right? Taking another example here, f of xy is sine inverse of x by y. You have to proceed the similar procedure, tx ty. So put x by tx and y by ty. So this is sine inverse tx by ty. So this is sine inverse x by y, and actually this one is t square f of xy, right? And this one is t to the power 0 f of xy. So this one is a f is a homogeneous function in x and y of degree 1, sorry, of degree 0. Okay, so in this matter you have to find like that, you have to find out the degree of the homogeneous function. You have to take another example here. F of xy is x square plus xy by x plus y. So now you have to find out the degree of this function, right? So this is tx ty, so this is t square x square tx ty divided by tx plus ty. Okay, so you get t square x square plus xy divided by t of x plus y. So you get t of f of xy, right? So this is a homogeneous function in x and y of degree 1. We have to see of homogeneous function. Now we have to see about homogeneous differential equation. Okay, let us discuss about homogeneous differential equation. Before go to the homogeneous differential equation, now let us discuss about the definition of homogeneous differential equation. Look, consider this differential equation m of xy dx plus n of xy dy. Okay, so this is a differential equation. Whenever this differential equation is said to be homogeneous, simple. If m of xy and n of xy are two homogeneous functions of the same degree, look at very carefully. This one, m of xy and n of xy are homogeneous functions and of same degree. Both have same degree. Then you have to say that this is a homogeneous differential equation. Now I give a procedure how you have to solve a homogeneous differential equation. This is simple, a procedure to solve a differential equation. Similarly, following this procedure, we have to take some examples, right? So now look at the procedure here. So this is n of xy dy is equal to minus m of xy dx, right? So now dy by dx is what? This is minus of m of xy divided by n of xy. In that case, you have to put let y is equal to vx. So this is dy by dx is what? V plus x dv by dx, right? So this one is v plus x dv by dx, and this one is minus m of x vx divided by n of x v x, and this becomes m minus n of 1 v. This is n of 1 v. Look at here, this is a function of v. Simply you have to take this is a function of v. X is cancelled out from the numerator and denominator, right? Same. Okay, now this becomes v plus x dv by dx is equal to f of v. So now we have to use the variable separable method. That means v to v side and x to x side. So this is x dv by dx is f of v minus v. Okay, so this is dv by f of v minus v, and this is dx by x. So you have to take integrations on both the sides, you get the general solution. So this is basically the procedure, how the procedure to solve a homogeneous differential equation. Now you have to take an example, right? Students, look at the example. Okay, first of all, you have to check this is a homogeneous differential equation or not. Look at here. Here 1, 2 plus 1 degree is 3, and look at here 3 and 3. So this is a homogeneous function of degree 3. Look at here, m of xy has degree 3, also n of xy has degree 3. So simply it is a homogeneous function. So that's why I have to solve. Okay, so look at here, solution is this is x square y dx minus x cube plus y cube dy is equal to 0. So this one is x cube plus y cube dy minus x square y dx. So minus is cancelled on both the sides. So this is dy by dx is x square y by x cube plus y cube. So simply we have to take let y is equal to vx, and dy by dx is what? V plus x dv by dx. So put it here. So this is v plus x dv by dx, x square vx divided by x cube plus vq x cube. Now x cube is cancelled out on numerator and denominator. From numerator and denominator, this becomes v by 1 plus vq, right? So now look at you, this is x dv by dx is what? V by 1 plus vq minus v. Okay, so this is v minus v minus v4 divided by 1 plus v cube. So this becomes minus v4 by 1 plus v cube. So now you have to separate the variables. This is, now you have to use this is the variable separable form. Now you have to separate the variables x to x side and v to v side. So this becomes 1 plus v cube by v4 dv dx by minus dx by x. So taking integrations on both the sides, you get v to the power minus 4 1 by v dv is equal to minus dx by x, right? So this becomes v to the power minus 3 minus 4 plus 1 divided by minus 4 plus 1. This is ln v, and this is minus ln x plus ln c. Okay, so this is v to the power minus 3 by minus 3, and take this to this side. This is minus, okay, this is ln c by x minus ln v. Okay, so this is becomes v cube 1 by 3 v cube. Okay, this is ln c by vx. Okay, so now this becomes e to the power, okay, minus is there, minus 1 by 3 v cube c by vx. So ln to this side, and this becomes this one. Now you have to put the value of v here. Look at here very carefully. Y is v by x, so v is y by x. So v is y by x. So put the value of v here. So what is the get? After putting the value of v, so this is minus y by y cube by x cube. So x cube minus x cube by 3y cube, and this one is would be y by x. So x is cancelled out. This is c by y. So simply y is take this side and this side, c e to the power x cube by 3y cube. So this is the solution. Okay. Now take another example. Friends, look at the problem. Dy by dx equal to y by x plus x sine of y by x. Here the degree is 1. Look at here. This is a function has degree 1 and this is also a function of degree 1. So now you have to simply solve this equation. Let y is equal to vx. So this is dy by dx is v plus x dv by dx. If you have to simply see that y by x is v. Okay. So this is v plus x dv by dx, and this becomes v plus x sine v, right? So now vb is cancelled out on both the sides. You get x dv by dx, it's x sine v. So x is cancelled out on both the sides. You get dv by dx is sine v. Simply you get this is dv by sine v dx, okay, and this one is cosec v dv, this is dx. Now you have to taking integrations on both the sides to get, and cosec v has integration is ln tan v by 2, and this is x plus ln c. Okay, so you have to take an integrating constant, that is ln c. So this one is ln, okay, I take the constant is c. So this is tan of v is what? V is y by x. So this is y by 2x, x plus c. So this is the required solution. Okay. So now you have to take two examples of homogeneous differential equation and to solve. Now we have to see some special forms of homogeneous functions. That means you have to reduce to homogeneous function. That means they are not in the form of homogeneous equations or homogeneous form, but we have to take some assumptions, and then after you have to make it a homogeneous function. So let us see. Let's talk about special forms of homogeneous differential equation. Look at this form. If dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. So this is the special form of homogeneous differential equation. If the differential equation in this form, there will be two cases. What are the two cases? Case one is a by a dash unequal to b by b dash, and case 2 is they are equal. A by a dash is equal to b by b dash. So there will be two cases, a by a dash unequal to b by b dash, and the case 2 is a by a dash equal to b by b dash. So there will be two cases, right? So now you have to solve for the first case, then after that we have to solve for the second case, right? So look at here. In that case, you have to take some assumptions. Let x equal to x plus h and y is equal to capital Y plus k, so that small dy by dx becomes capital dy by dx, right? Okay. So this one is capital dy by dx is what? A capital X plus h b y plus k plus c divided by a dash x plus h b dash y plus k plus c dash, right? So this becomes ax plus by and ah bk plus c. Okay, now this one is a dash x plus b dash y plus a dash h b dash k plus c dash. Okay, let us assume a, b, c, d, e, f, g, h, I, j, k, l, m, n, o, p, q, r, s, t, u, v, w, x, y, z. So this is let us assume ah plus bk plus c equal to 0. That means you have to choose h and k in such a way that ah plus bk plus c equal to 0 and a dash h plus b dash k plus c dash equal to 0. You have to choose h and k in such a way that these two equations becomes 0. So you have to take you have to solve these two equations and you get the value of h and k. When you have to take examples, you have to understand very clearly, right? So now this one is dy by dx becomes ax plus by divided by a dash x plus b dash y. After that, similarly, you have to take y is equal to vx. This becomes homogeneous, right? Vx and dy by dx is what? B plus x dv by dx. After that, you have to solve the same procedure for homogeneous differential equation. This becomes a homogeneous differential equation and you have to solve like that, y equal to vx, and you have to follow the same procedure I have to tell later. Okay, now you have to take some example. Okay, so look at the example here. Let's look at the problem here. Okay, first of all, check it here. This is 1 by 1 and this is 1 by minus 1. So this is actually the first case. That means a by a dash unequal to b by b dash. In that case, you have to choose let small x capital X plus h and small y as y plus k, so that small dy by dx becomes capital dy by dx, right? Okay, now I have to put in the given equation. So now this is dy by dx. Small dy by dx is x plus y plus 4 x minus y minus 6. It becomes capital dy by dx. Okay, this is x plus h and this is y plus k plus 4 and this is x plus h, this is y plus k minus 6. Okay, so this becomes x plus y, x plus k plus 4, and this one is x minus y and this is h minus k minus 6. So choose h and k such that h plus k plus 4 equal to 0 and h minus k minus 6 equal to 0. So you have to solve this two and you get values of h and k. Okay, let's forget it and look at here. This one is dy by dx is what? X plus y divided by x minus y. If you have to see clearly, this one is a homogeneous equation, right? X plus y has degree 1 and x minus y has degree also 1. So this is m of xy divided by n of xy and have degree 1. That is the same homogeneous functions. Okay, m of xy and n of xy has same degree, right? So that's why I have to take let y is equal to capital Y equal to capital Vx. So this is dy by dx is what? V plus x dv by dx, right? So now this becomes x plus vx and x minus vx. This is v plus x dv by dx, right? Okay, so this becomes v plus x dv by dx 1 plus v by 1 minus v, and x dv by dx is what? This is 1 plus v by 1 minus v minus v, and it becomes 1 plus v minus v plus v square divided by 1 minus v. It becomes 1 plus v by 1 minus v. This is 1 plus v square by 1 minus v. Now you have to separate the variables. Okay, v to v side and x to x side. So this becomes 1 minus v divided by 1 plus v square dv, and this is dx by x. Okay, so taking integration on both the sides. So this is dv by 1 plus v square and this is v by 1 plus v square dv. This is dx by x. Okay, look at very carefully. We know the integration of this one, but this one, look at very carefully. This one derivative, I have to tell an formula f dash x by f of x dx, that is ln of f of x. Okay, so if derivative of the denominator is in the numerator, then that is the ln of that function. Okay, so this one is, look at very carefully, derivative of 1 plus v square is 2v, so that's why I have to multiply 2 on the denominator and to divide 2 and multiply 2, right? So this becomes tan inverse v, and this one is half ln 1 plus v square, and this is ln x plus ln c, right? So this one is tan inverse v, and it becomes ln cx. Okay, this is cx, c capital X, right? Cx plus ln 1 plus v square square root. Okay, so this one is ln cx into 1 plus v square, right? So now this is, we know that v is y by x, so this is tan inverse capital Y by x, okay, ln cx 1 plus y square by x square, okay. So this one is ln x is cancel out, c x square plus y square, okay. But now we have to solve these two equations. We get, what are the two equations here? We have to add these two equations. This is 2h minus 2 equal to 0, so that's why h is 1, okay. And what is the value k? So h plus okay, h is 1, so 1 plus k plus 4 equal to 0, so that's why k equal to minus 5. So h is 1 and k is minus 5, but we have to take small x as x plus h and small y as y plus k. So this is capital X is what? So capital X is x minus h and capital Y is small y minus k. So that means here capital X is x minus h, that means x minus 1, and capital Y is y plus y. So put in the place of capital X by x minus 1, small x minus 1, and capital Y by y plus y. So now this is tan inverse y plus 5 divided by x minus 1, and this is ln c small x minus 1 whole square plus y plus 5 whole square, and this is square root 1. Okay, so this one is the solution of the given differential equations. Okay, now we have to take the second case. Okay, look at the second case here. The second case of special form of homogeneous equation is quite easier. Look at here. So this is dy by dx is ax plus by plus c divided by a dash x plus b dash y plus c dash. Here the case 2 is what? This is the case that a by a dash is equal to b by b dash, right? So take 1 by lambda say, okay, so it becomes a dash is a lambda and b dash is b lambda, right? So now this is dy by dx, okay, so it becomes a x plus by plus c divided by put a dash by a lambda x plus b lambda y plus c dash. So this becomes ax plus by plus c divided by, take common lambda, this is ax plus by plus c dash, okay. So after this, just put, let ax plus by z, so this becomes a taking differentiate on with respect to x, this is b dy by dx is what? Dz by dx. So what is the value of dy by dx? Dy by dx is dz by dx minus a divided by 1 by b. So now this equation becomes dz 1 by b dz by dx minus a z plus c divided by z minus z plus c dash lambda z plus c dash. This equation becomes a variable separate. This is a variable separable form. You have to separate the variables and you get the solution. Now let's take an example. Dear students, look at the example here. Dy by dx is what? X plus y plus 4 divided by x plus y minus 6. Look at here. here 1 by 1 is equal to 1 by 1. So a by a dash is equal to b by dash. The case 2, special forms case 2. So that case you have to take let x plus y z. So this becomes 1 plus dy by dx is the dz by dx. Okay, so dy by dx is what? This is simply dz by dx minus 1, and this becomes dz by dx minus 1 z plus 4 by z minus 6. This is dz by dx is what? Z plus 4 by z minus 6 plus 1. So now dz by dx is what? Z plus 4 plus z minus 6 divided by z minus 6. This is 2z minus 2 by z minus 6. Now we have to take 2 common, that is 2 whole into z minus 1 by z minus 6. Okay, now I have to separate the variables here. Z minus 6 by z minus 1, this is 2 dx, right? And this is dz. Taking integrations on both the sides, you get, that is, this is actually z minus 1 minus 5 divided by z minus 1 dz twice of dx. Okay, so this becomes 1 minus 5 z minus 1 dz equal to twice of dx. So this becomes z by 5 ln z minus 1 plus equal to 2x plus c. So this is x plus y minus 5 ln x plus y minus 1 equal to 2x plus c. And the solution is actually y minus x minus 5 ln x plus y minus 1 is equal to c. I have to just take 2x to this side. This will become y minus x minus 5 ln x plus y minus 1 mod equal to c. So this is the required solution. I hope you have to understand how to solve a homogeneous differential equation. In this class, basically we have to discuss about what is homogeneous function and the definition of homogeneous differential equation and how to solve a homogeneous differential equation. After that, you have to see the special forms of homogeneous functions. That in the two cases, a by a dash is equal to b by b dash, the second case, and the first case is a by a dash unequal to b by b dash. Okay, I hope you have to understand all the concepts today I have to say. If you have any doubts, ask in the comment box, or you can directly join in our WhatsApp group. So thank you to all of you. See you in next class.